The next rules I wanted to focus on are what happens if I take an exponential expression or a different algebraic expression, such as a product or a fraction, and I raise those to a power, what happens? So the first rule of these says that if I have a to the m power and I take that whole thing and raise it to the n power, what I'll be left with is a raised to the m times n power. Basically, and sometimes I refer to this as a chain or a stacked exponent. When I have a chain of exponents, it always turns into multiplication of those two values. So let's look at an example. Again, let's stick to something we've been dealing with. Let's just say 5. Let's say we had 5 cubed, then squared. What that rule suggests is that this should be equal to 5 to the 6th power, because we should just multiply those two things together, and that's that. And if you're wondering, well, should I actually multiply it out? Yes, you could, but a lot of times when we're dealing with numbers to large powers, if you multiply 6 5s together, that gets really, really big, and it might be impractical to actually find that answer. Sometimes it's simpler just to leave it as 5 to the 6th, but at the end of the day, we're simplifying the expression and changing this stacked exponent into a singular case. And one other thing, while I'm on the subject, is that if you see something like this, if there's no parentheses around it, this is actually different, because what this would imply is that this is 5 to the 3 squared. 3 squared is obviously 9. Those would not multiply together, right? Because that wouldn't make any sense. And this is just a slightly different scenario than this. And if you're wondering which it is, well, the parentheses are what help us to know it's this whole thing squared, not just the 3 itself. But also, okay, so why? And again, the question of why these things work always comes down to, well, what does exponential notation mean? 5 cubed means, well, I just have 3 5s multiplied in succession. And if that whole thing is squared, well, that means I have 2 of those whole things in parentheses multiplied together, because that's what squaring means. So altogether, I have 5 times 5 times 5 times 5 times 5 times 5. Ultimately, that makes 6 5s all multiplied together, which is why it comes out as 5 to the 6th, right? Because really, this just means I have this many groups of this, and if I have a certain number of groups of something else, that always is a multiplicative effect, right? That's why we end up multiplying 3 times 2 to get 6. Now, it can be really easy to mix these situations up and accidentally add these, because that's that other rule we talked about in the other video. But again, how we can... This is really how you know which rule. It's because it just makes sense. And if you ever are stuck or confused, that's why I'm going through it in this way, so that we can go about and think about, well, it should make sense which rule works, right? Because ultimately each rule is built on sense. It shouldn't be something you have to memorize, because it just, in a perfect world, it would all just kind of seem correct. Now, looking at the other two rules, if I have AB raised to the n power, what it says is that I should take each part individually and raise them to the n individually. And what we're not to get confused is that if there was adding in here or subtracting, this rule would not work anymore. This rule only works when we have either multiplication or division on the inside. Kind of like I said up here, the same rule doesn't work for adding and subtracting. And when we get into polynomials and such, we'll kind of talk about that. But with polynomials, we mix in adding and subtracting in with all of these things, and it can be a little bit more complicated with all of those components put together. So let's try to think about why those are true. So let's say we had, say, 5x, and we wanted to then square it. What the rule suggests is that I should just square each one of them, 5 squared, x squared, and that should be my answer, which of course would be 25x squared, and that would be it. Cool. And again, why? It's kind of the same reason as the last one. If I have 5x squared, that just means, well, 5x times another 5x, because the whole thing is squared, meaning the whole thing is repeated twice. And if I have 5x times 5x, of course I could multiply the numbers together because I know what those are, and I can multiply the variables together because I don't know what those are. And of course, x times x is always x squared, because that's what squaring means, right, is when I have the same thing multiplied together. And it's really the same thing for a fraction. Say, for example, I had 4/5 squared. Again, that would just mean 4/5 times 4/5, which by rule of fractions would give me 4 times 4 on top 5 times 5 on bottom, but that would of course equate to 4 squared over 5 squared. Basically, the exponent will spread across to the top and the bottom, the numerator and denominator of that fraction separately, as the rule says.